Master Engineer Kojury share the screen and start the talk. Master Kojury.
Hello everyone, greeting and good health to all of you dear ones. In the continuation of the points presented by the dear speakers,
Hello.
I will provide some points regarding the application of energy awareness in the smart grid entitled Smart Energy Aware Cities, Customer Energy Data Analytics for Smart Demand Response Implementation. This application focuses on the use of customer consumption data to improve demand response program, which is one of the most popular demand side management programs. And the structure and order of presentation in this lecture is as follows. At the first, preface and some needed points about the points and concepts used in this lecture are described. Then the methodology used in this lecture and study is described. Then the methodology is implemented, and at the end, conclusion and summary of the points described are will be presented. Okay, in this study we have some goals described here. The first one is a customer characterization for cluster analysis according to their consumption data. Second one is determining customers' capacities for participating in demand response in the case of different percent of load reduction. The third one is analyzing variation and approximation of the estimated and observed capacities for different clusters. In the context of a smart grid, demand-side management programs are some necessary points in which customers' role is very embossed. In other words, when you are talking about demand-side management program, you need participation of consumption side of the grid, by which you could save energy, you could reduce your costs, and you could use the saved energy in some critical times of the consumption periods, such as peak periods and other things like this. In this picture, we have a conceptual picture about position and condition of demand response in the context of a smart grid and energy-aware smart city. As it's presented, we need for achieving energy-aware smart city and to have, in other words, to have a smart city, we need to have a smart grid. A smart grid has some elements, some components. One of which is a smart demand response. Demand response and other points about it are presented and described in the next slides. But this slide says about whole overview of the points we intended to say. In the next slide, as is presented, we have described some components associated with a smart city. A smart environment, a smart living, a smart mobility, a smart economy, a smart people, a smart governance. These 6 components are covered by some necessities. Necessities such as human factors. Human factors are factors such as demographic points, as we know about human style of living, their behavior in energy consumption, and something like this. Technology factors. Technology factors is very important in realizing a smart city and a smart grid. As you know, one of the most affecting and influencing point in realization of a smart grid is technology development, monitoring, metering, and some technologies like this that is mentioned in so many papers concerning this point. Another one is institutional factors. It means some institutional and legal points for having this new situation in people's life and other things like this. But what's the main question in this presentation or in this study we have two questions, as you know. One of them is how customers play a role in realization of a smart grid in the context of a smart city. And another one is how a smart demand response is implemented regarding customers' consumption patterns. As mentioned before, I mentioned before, a customer's role is very important in realizing demands a smart demand response, and it needs analyzing consumption data using especially data-driven and data mining techniques. Okay, a smart metering and monitoring technology is a key feature of a smart grid implementation of demand program. Deployment of such, I'm sorry, is there any point? Can I continue? Can I go on? Is everything okay?
Yes, Mr. Kojury, you can continue. Okay.
Yes. Thank you. Deployment of such technologies in the distribution network enhances awareness of different parts associated in the electricity market. As customers are the players of this market, enhancement of energy awareness about them causes their better participation in such programs. This better participation refers to actions and the decisions by which benefits of the both customers and utility sides of the grid from implementation of demand response be made. Suitable implementation of demand response program is a key step in the realization of a smart grid and in the next step, a smart city. Customer characterization is needed to perform to determine capacities of the customers with different consumption patterns for participating in demand side management programs. We believe that the customers with different consumption patterns do not necessarily have the same effect on implementation of demand side management programs. In other words, as you know, customers do not show the same consumption behavior, consumption pattern, and the load profile as a whole in different time zones. And actually, they don't have the same effect on the whole load profile of the grid. So it's needed to be analyzed, their consumption, to be able to select the most susceptible group of customers for participating in demand side management programs, not all of them. For this reason, customers are clustered according to their consumption patterns, and demand response is implemented using these customers to determine capacities of each one of these clusters. As you know, we can't analyze all of the customers one by one or each one as an individual, because each customer's energy consumption lonely is very small, is very low to affect the total load shape of the grid. But when you put customers with similar consumption pattern in a same cluster, you could use this cluster instead of all of the customers dedicated to this. Okay, and now we are talking about each cluster. Each cluster means each consumption profile, each consumption pattern, each consumption behavior. All of the customers dedicated to each cluster have the most similarity to each other in their consumption behavior. Customers' capacities basically root in their welfare to choose a specific consumption behavior. According to their welfare, customers reduce their consumption in different hours to meet both their welfare and economic consideration in the consequence of load reduction in times of high price. As you know, in peak periods, usually electricity prices are high, and customers would reduce their consumption in these periods to save money and reduce their consumption, reduce their cost. Motivation of the study. Assessing the role of new metering technologies in the electricity network in a smart city, studying the effect of enhancing customer awareness on the implementation of demand response programs, recognizing challenges of extending new technologies for improving monitoring infrastructure in a smart city, recognize and defining new opportunities provided by enhancement of awareness in customers and other participants of the smart grid. And then about the demand side management. As I mentioned before, demand side management is the planning, implementation, and monitoring of those utility activities designed to influence customer use of electricity in ways that will produce desired changes in the utility's load shape. In other words, in DSM programs, some instruments and techniques are utilized to induce customers have a consumption pattern which is suitable from utility companies or grid operators' point of view. In other words, we need to dissipate consumption in different hours to have approximately a smooth consumption profile, load profile. But as you know, we have some peak periods, for example, early of the night, in which lights are on or other consumption, other devices are on in these times. In this situation, in this condition, usually some programs which are known as demand side management programs are designed and used to induce customer to shift their consumption from peak period to off-peak periods, or in times we don't have so much consumption. In the context of DSM, demand response is one of the most popular programs. In the next slide, I think because we want to concentrate on demand response, we better talk about it. Okay, demand response program. Demand response program in general is divided in two types: price-based demand response and incentive-based demand response. Each one of them have some other types or subsections, as you know: time of use, real-time pricing, critical peak pricing, and other one, emergency demand response program, direct load control, and as is shown in the picture. In this slide, we have some little description about price-based demand response and incentive-based demand response for more information about this. As is mentioned, the price-based demand response refers to the changes in usage by customer in response to changes in the price. They pay and include real-time pricing, critical peak pricing, and time of use, which are types of this demand response. Another one is incentive-based demand response. Incentive-based demand response are established by utilities, load-serving entities, or regional grid operators. These programs give customers load reduction incentives that are separate from or additional to their retail electricity rate, which may be fixed or time varying. In other words, you as a customer will receive some money or some incentive to reduce your consumption intentionally in peak periods to help the grid for serving electricity to their customers. Okay, the methodology used in this study is as shown in the picture. In the first step, we should gather raw data from different data sources, as it's mentioned. This is customer consumption profiles recorded by smart meters, as I mentioned before. The role of technology in this study and DSM issue is very important, and as metering is more smart, and data are achieved with high resolution. the quality of them, and accuracy of the results will be more. The next step is preprocessing of data set. Preprocessing actions are applied on the data set. In the next step, customers' load profiles are allocated to some clusters according to the similarities in consumption. Clustering and other techniques in the context of data mining, I think needs to have another separate presentation about that. And but as I know, there is enough information and knowledge about data mining and data science techniques with audience. I ignore them and continue with the next page. Constructing model. A model is constructed to implement demand response. For demand response, we need to select a model, and as I mentioned before, we have some different types for implementing demand response. One of them is selective. In the next step, demand response is implemented on different clusters, as I mentioned. Then estimation phase, in which capacities of different clusters for participating in demand response is estimated using the results of the prior stage. It means when you implemented demand response programs, you have the knowledge about customers participated in this program. As I mentioned before, customers are dedicated to some clusters. Different clusters actually have a specific consumption profile, representative consumption profile. These consumption profiles are compared with the suitable and desired consumption profile from its operator point of view. By such comparison, each cluster's capacity for affecting or influencing demand response program or for reducing consumption in peak times and peak periods will be achieved. Okay. In the next slide, as it's mentioned, modification of the model is performed, in which the estimation model is modified in the consequence of implementing demand response for several times. After implementing demand response in the first time, we have a sense of different clusters capacity for affecting peak shaving or peak reducing from all over the grid. Okay, and for getting and achieving more accurate sense and more accurate knowledge of different clusters capacity, we need to implement demand response for several times. It would modify the capacity achieved in the first time of implementing demand response. In the next step, evaluating demand response, the capacity of different clusters for participating in demand response, and the implemented demand evaluated in this phase. In the next phase, the role of the AMI enabling implementation of demand response program is evaluated, and this is the next. This is the last step in this study. Okay, in the phase of implementation, we need a case study on which the described actions would be implemented. A real data set is used here to evaluate the proposed method for analyzing customers' capacity for participating in demand response. The data set is recorded energy consumption of 1200 households in an Irish distribution network in 13-minute intervals provided by ISSDA site, and we should acknowledge them for receiving this data set. This data set about this 1200 households is implemented and dissipated on a 69 buses test case, as it's shown in this picture. And these customers are dedicated in 24 clusters. The procedure of determining the optimum number of clusters is a separate issue, and as I think we don't have enough time, I ignore it. And as you know, determining the suitable and optimum number of clusters is a very important point in having a good pattern recognition and customer characterization context. Okay, in the next slide, we have the results of implementing the described methodology. As you see, we have two curves, red and blue curves, which show electricity consumption profiles after and before and after implementation of demand response for some example clusters. As cluster number 1, cluster number 2, as I mentioned before, we have 24 clusters. And in these slides, we show this. As you know, there are some differences between these clusters and load profiles and electricity consumption and the electricity consumption load profile after demand response have approximately a smooth trend. Okay. In this slide, differences capacities for participating in demand response for different clusters, as we know, 24 clusters are presented, and in this picture, estimated capacity and observed capacity are compared with each other. As you see, in some cases, accuracy of the model is considerable, is acceptable, and it's needed to be mentioned that demand response implementation is implemented in 4 scenarios. Scenario number 1, load reduction is assumed to be 10% of total consumption. Okay, it means you as a customer participating in demand response, reduce your consumption just 10% from your main consumption. Okay, and this is the this picture shows the approximation of estimated and observed capacity. As you see, for some clusters, it's very good. The approximation accuracy of the model is very good, and in some others not. Okay, because some customers, as we repeated for different times, some customers do not obey a regular electricity consumption behavior, and they change their consumption behavior. So the model needs more and more implementation to get a better accuracy. Okay, but some other not. Some other approximately have a same and regular electricity consumption behavior and obey that one. Do not change their consumption behavior very much. Okay, other things is for 20% load reduction. And this one, this is for 30% load reduction, and this one, and another one is for 40% load reduction, and this one. Okay, as you see in these pictures, approximate accuracy of the model varied in the context of increasing load reduction percent. It means, for example, for a cluster, a specific cluster, for example, cluster number 2, when you are talking about 10% load reduction, the accuracy of model is a specific value, it has a specific value. When you are talking about 20% load reduction, this accuracy changes, and this is a very good capability of having a data-driven attitude. by which you can monitor all of the detailed points and all of the detailed changes. It means, for example, I'm a customer in real words. I'm a customer. I don't have problem to reduce my consumption a little. For example, 10%. Okay, and it doesn't disturb my welfare. But when I be requested to reduce my consumption, for example, 10%, I will show another behavior. It will disturb my welfare and necessitates me to choose another consumption behavior. So it will be different. This new consumption profile will be different from estimated consumption profile in the mind of system operator about my consumption. So this is a good point for tracking customers' attitude in their consumptions. This is the main point caused staying smart people in a smart city. It means you can get more efficient decisions according to your welfare, your benefits, considering system and network requirements. Okay? In the next slide, in summarized and very small points, we have some conclusion points as such. The first one, utilizing data-driven techniques for customer characterization reveals key features in customers' consumption patterns, some of which are mentioned by me in the prior slides. Another one is customers with different consumption patterns show various capacities for participating in demand response programs, and customers' capacities for participating in demand response varies in different percentile load reductions. As I mentioned before, customers choose their consumption behavior according to their benefits, and if system operators need to use of customers for realizing better implementation of demand-side management programs, they need to know about their consumption, their customers' consumption behavior and attitude more, or which group of customers could receive or are eager to receive incentives for reducing their consumption patterns, and which other not. Thanks a lot. Thanks a lot for your beautiful patience. If there is any question, I eager to hear, and I wish response.
Thank you so much, Mr. Kojury, for your great presentation.